Our programming time, I would say, came down 80%. So that alone, I think, is worth every bit of it. Vineburg Machining is a mass production machine shop, and we have specialized ourselves in the complicated and the tough parts many people don't like to play with, especially castings, because there are a lot of great challenges to overcome with that, and we have become very good at it. We basically poke holes in it or machine features onto a casting for all kinds of different industries, you know. The challenge with the castings always are the fixturing, and we've gotten very good at it. We are a tier 2 supplier to Peterbilt, a Packard. We machine castings for a local foundry up the hill. It's PPF. You know, Ingersoll Rand is one of our customers. We machine parts for companies for all around the world. So I can say that I had parts in the Tour de France 2 years ago. Wow. I had parts at the Sydney Olympics. I can go anywhere in the US and find stuff we make. That's pretty cool. Vineburg Machining originated with Acme screw machines in 1977, and that slowly has diminished a little bit. Now we're down to 7 machines from 34 at the highest. So you'll see a screw machine department with 7 screw machines running at this point, and then we have a CNC department. That's our biggest production space right now. And we have 8 milling machines and 6 lathes, 4 or 5 axis machines, and that has been the biggest growth we've seen so far. So a very good customer of ours had a very challenging part, and he told us basically that there were only 2 companies in the US who can make those parts, and they are very expensive parts. And he said to me, I can have a 1,000-piece order if I could just make the part. And that part has a very challenging 3D surface. There's some very challenging features on the part. And the software we had was not able to help us with that. And we start investigating the right software over the web and so on. I had some web sessions where they show your stuff. I flew to IMTS to really, sort everything out because everybody is right there. Mm-hmm. And then we ultimately settled with SolidCAM. The great thing about that was they helped me program that first challenging part right over the phone basically, and having a web seminar. So it was great. I had instant help. Right. Where everybody else, I wanted somebody to help me Sunday afternoon if I wanted to, because that's sometimes I'm reworking. Yeah. That's just how we got down to SolidCAM. We're using it every day. I actually deleted the old software we used just to make sure we force all of our employees to use it. We have about 6 SolidCAM users here. We have 2 dongles, so we have 2 active computers at all times. We're using SolidWorks for everything we do. Oh. And then you have SolidCAM right inside SolidWorks. You have the raw casting you can use as your stock. You have everything right there 3D on a spot. Mm-hmm. And the programming alone, we're running this one casting out here. It took me like an hour to program the whole job. And it's a total 5-axis job with, 6 different angles and all kinds of different features and fixtures and clamps involved. And there's always clearance issues. And SolidCAM tells you if you're going to run into a clamp. You can program right around it. It's perfect. We like to machine a lot of heat-treated steel. It's much more beneficial for machining process, I think. And the amazement we had right from the start was how accurate, number one, the cycle time was, the estimated cycle time inside SolidWorks, and the accuracy of the part coming out. I mean, it was incredible. We start using iMachining when nothing else would work. When you do one traditional way of thinking for a long, long time, it's tough to kind of jump into it. The first time we used iMachining, we had to machine a very small, tiny fixture for a part. Mm-hmm. I want to just see how iMachining works. I programmed the whole pocket with a 1/8 end mill. And not only it took like a half-inch depth of cut, but it machined the whole pocket in like one shot and looked beautiful. And the tool didn't break like you would anticipate it with any other way of doing it. And since then, we really started using it a lot. My guys are always, they're amazed when they program something and they thought it would never be possible. And the accuracy of the simulation is like, sometimes there's this little tiny nick in a simulation, you don't believe it's actually going to happen on the part, and it's right there, it's perfect. Our programming time, I would say, came down 80%. So that alone, I think, is worth every bit of it.